Hello there. My name is Adithya S, and I'm a student from PS University. I chose Scenario 3 Community Safety and Digital Wellness. The reason why I chose this scenario is because I believe it is very prevalent in our current times, wherein people use a lot of social media, including me. And there are like global crises like taking place everywhere, like with the war, and so there's been a lot of misinformation that's been spreading and a lot of alert fatigue as well. People today face massive alert fatigue, local safety information and digital security threats are scattered across social media, often presented in a toxic and overly anxious way without clear actionable steps. So that is why I'm proceeding with this scenario. So before I jump into the demo of the prototype, I'd like to briefly go over my thought process, design choices, and technical stack. So the tech stack I used was React with Vite and Tailwind CSS, and that was the front end, and the back end is Fast API and Python. So why React? React is like the one of the most commonly used front end frameworks. We can easily ensure like a clean and accessible UI. Uh, and for the backend, I chose Fast API because of its built-in pydantic validation. So for these other frameworks like Django REST framework, for example, you would have to write serializers just for the data validation. But here, Fast API automatically validates it using pydantic, and it also has excellent routing capabilities. So for the AI tool, for the LLM, I used Google's Gemini, which is free for the developers, and I believe I'm using Gemini 2.5 Flash model. And the trade-offs I made for this particular prototype was to stay within the time limit of 4 to 6 hours. I decided to use only a JSON file for the data rather than using like a proper full SQL database. I also like to say that I made sure to use best practices such as using a skill file. So this is the skill file I have. I've pushed this to the GitHub repository as well. Let's start off with the live demonstration. I've already like booted up the website. So this is the command to run the front end, and this is the command to run back end. One other thing why I chose FastAPI is because it also provides documentation using Swagger. Yeah, on proceeding with the demonstration now. So this is the main feed dashboard. So we have the incidents for this neighborhood downtown here, right here. So again, all these incidents are given from the obtained from the JSON file. So we have three different types of incidents here. One is a verified alert, another is a noise complaint, and another is a digital threat. So if you want to say generate digest, this will make like a summary of all the incidents in this neighborhood to the LLM, Gemini LLM. So it takes a bit of time because it's a free model. Now we can go to the report. Now here I'm also using categorization. So summarization was one feature of the AI. Another feature is categorization. So say I want to like submit an incident report. Let's try triggering the categorization properly, such that I'll try like a verified alert one. So you should be able to properly categorize it as such. So let's start off with the verified alert. So this should make a post request. We'll see, and this is also processing via API via the AI. So this will categorize it as yeah, verified alert. There we go. So we ensured both the proper post request is made, yeah, post request, and the AI is also categorizing it correctly as a verified alert. Next, we can show a bit of CRUD, I'd say. So we can, edit this. We can also do something called verify to show that, it's like something which is trusted and approved by your fellow neighbors. And let's try editing this, shaking the walls in ABC Street. And yeah, ABC Street now. Let me just quickly verify it by Going back and checking if it's being saved. Yeah. Now we have another feature. Okay, so that's get done, create done, update done, uh, create, update, read done. Read is also done. It fetches all the incidents. And we can finally do a delete operation, which is just dismissing this. And there we go. Let me just quickly verify if it's being done. Yeah, that is no longer there. And the final feature is safe circles. So also has been generated from a JSON data, synthetic data. This is actually meant more for the future scope, where you have like proper user authentication and you can invite users to the safe circle and perhaps use something like a Twilio to trigger SMS messages whenever one of these is triggered. So let's just say for now I made like a simple like three categories: safe at home, need assistance, everything. So say need help at 123 street. So this will immediately come here at the topmost part, and we can make another update saying I am safe now, thank you. And that's about it. Now we can take a look at the code. I will quickly show. Before that, I'll also show the test cases. I most notably use four scenarios, I believe. So one is like a happy path. One is a happy path, and one is, yeah, this is a happy path where it validates correct incident passing, AI integration routing, and pyrantic schemas. And then we also have edge cases. Yeah, edge cases right here. Let's quickly run the test file. Yeah, so we can see all four passed, and that's about testing. Yeah, my main takeaway from this challenge was the importance of deterministic parsing when working with LLMs. So extracting JSON cleanly from the LLM response required like strict prompt engineering, but pairing it with like a robust non-AI fallback also made the application incredibly stable. Let's say. I'm concluding my demonstration here. Thank you for taking your time to review my submission.